Alright guys, so today we're going to talk about two rules, and the first one is called the multiplication rule. Multiplication rule. Alright, and the multiplication rule states that if you're trying to find two probabilities, probability of A and probability of B, and you're given a sample space, then the probability, and here's your sample space, then the probability of A and B is equal to the probability of A times the probability of B divided by the probability of B. If you're given that the events are independent, then the probability of A and B, you can just multiply probability of A times the probability of B. So this is defined by the multiplication rule. Alright, next we're going to go over the addition rule. Which states if you are given the probability of A and the probability of B, and they are defined by a sample space, then you can calculate their probabilities if you're trying to find the probability of A or B happening by taking the probability of A plus the probability of B divided by the probability of A and B, which we talked a little bit about yesterday. Oops, I did make a mistake, and then we're going to subtract the probability of A and B. This is the one that we spoke a little bit about yesterday, and the reason we have to subtract A and B is because if the two are defined within a specific sample space. If the two events are mutually exclusive, which we defined as mutually exclusive events, then the probability of A or B would be equal to the probability of A plus the probability of B. Because when we look at mutually exclusive events, they don't have any overlap in a Venn diagram. The probability of A does not overlap with the probability of B. Okay, now we're going to pretend we are playing basketball. So here we have our basketball. Okay, and we have two shots. The probability of making the first basket is 0.65. The probability of making the second basket is also 0.65. but we tend to shoot better if we make our first basket. So the probability of B given A occurs, we're going to say is 90% or 0.9. All right, first let's ask ourselves, is this mutually exclusive or independent? Well, since our probability is going to change based on what happens for our first attempt, for our second attempt, then the events are not independent because the probability of A is dependent on B. And therefore not independent. So which of these rules, the multiplication rule or the addition rule, should we not use? Therefore, we cannot use the multiplication rule to find the probability of A and B occurring. Okay, so let's go over this. Well, for the probability of A and B occurring, well, we have the probability of B given A occurs, which is what this sign means, is equal to 0.9. We can't just use the probability of A because we know that B is dependent on A. So instead we need to use the probability of B given that A occurs and the probability of A for our multiplication rule. So the probability of A and B occurring, we need to use the probability of B given that A already occurred if we're making both goals times the probability of A. So the probability of B given that A occurred is 0.9 and the probability of A is 0.65. And we're going to multiply these together and we will get that the probability that we make our first and second baskets is 0.585. 0.585. All right, now we're using the same example. We're shooting our basketball and we want to find the probability of making the first basket or the probability of making our second basket. So we have the probability of A or B occurring. And if we remember our rule for ORs, it's the addition rule. So we need to find the probability of A occurring plus the probability of B occurring minus the probability of A and B occurring. So we found this before. We know probability of A was 0.65. The probability of B occurring was also 0.65. And we just calculated the probability of A and B, which if you remember, the probability of A and B we calculated before was 0.585. 0.585. Okay, so after we add all of those together, we would say the probability of making the first or the second basket is 0.715. 0.715. Okay, now let's ask ourselves, is this event independent? No, because the probability of B and A occurring are dependent on each other. Remember that the probability of B given A was 90% or 0.9. If you took that and went back and compared it to the multiplication rule, we don't get the same number. So let's prove that for a second. So to see if it's independent was the probability of A and B the same as 0.65, which was the probability of A, times 0.65. No, it was not equal to our 0.585. Because if you did the math here, 0.65 times 0.65 is equal to 0.43. Is equal to 0.423 rather. Is equal to 0.423, which is not equal to 0.585. And therefore, you'll see me use these three dots. These events are not independent. They depend on each other. If A happens, then B has a greater chance of happening. Okay, now let's find out, are these events mutually exclusive? Are these events mutually exclusive events? Well, if they were mutually exclusive events, the probability of A and B happening must equal 0. The probability of A and B must equal 0. Well, we found the probability of A and B happening right here, which is not equal to 0. And therefore, these are not mutually exclusive events. Okay, here's another example. We have 150 people trying out for a sports team. 75 of these people make the JV team, 47 of these people make the varsity team, and the rest are cut. We are going to solve for different questions related to this information. Out of these 75 people on the junior varsity team, 40 practice 4 times per week. Out of the 47 on the varsity team, 30 of these people practice 4 times per week, and the rest that are cut, 10 of them keep practicing 4 times a week. So first, we're going to pretend we're selecting a person at random, and what is the probability that this person made the varsity team? To find the probability that the person made the varsity team, we know that 47 of these people made the varsity team. And our total sample size was 150. So 47 out of 150 would give us our probability that the member is a varsity team member. And if we can reduce this fraction, we are going to want to reduce this fraction, but we cannot reduce this fraction. Okay, now let's solve for the probability if we select one person that person practices 4 times per week. So let's see the probability that one person that randomly selected practices 4 times per week. For this one, we would have to add up all the people that practice 4 times per week, which is 40 plus 30 plus 10. That would give us 80. Out of the total number of people, which is 150. But we can reduce this to 40 over 75 if we divide by 2, and then we can reduce it to 20 over 35, and then we can reduce it, if we divide again by 5, to 4 over 7. So if we select a person at random, 4 out of 7 chance probability that that person will practice 4 times per week if we are reducing the fraction. Okay, what is the probability that an varsity team member practices 4 times a week? So we're looking for the probability that it's a varsity person and they practice 4 times per week. When we have this and, we have to use one of our rules. So the probability that they're varsity, we calculated, was 47. Probability varsity, we calculated, was 47 over 150. The probability that they practice 4 times per week of them being on varsity times the probability of them practicing 4 times per week. And then we are going to divide it by the probability of them practicing 4 times per week. So the probability of them being on varsity, we saw, was 47 out of 150. The probability of them practicing 4 times per week, we saw, was 80 out of 150. However, we can't use this because this would use the entire sample space we were given. Instead, we want to use the probability of A being true and then the probability of B being true given A to calculate this probability. So instead of using the entire sample set, which is using this number, we want to use the sample set of B given A is true. So if we know A is true, which is they're on varsity, we have 47 people on varsity, and we know that 30 of them practice 4 times per week. So instead of using our total number of our sample space, we need to use the sub-sample space of 40 people practicing 1 time per week. So the probability of B, given that A is true, would use our subset, which is 47 people. And we know how many people practice 4 times per week on varsity. Well, we know that 30 of them practice 4 times per week on varsity. So to get this answer, we can also use the probability of B given A times the probability of A. All right, now we're going to go to our calculator. 30 over 47 times, what was our subset? B given A, 47 over 150. And we get 0.2, or you can change it into a fraction, 1/5. So we should have gotten 1/5 as our answer. All right, let's finally describe these as mutually exclusive and independent events. Okay, to see if they're mutually exclusive events, we have to think about all of the possibilities. Is being on varsity mutually exclusive event compared to being on JV? Can you be on JV and varsity at the same time? Well, maybe that's true, but in this case, no, right? Because we have the rest are cut. Nobody's being on both JV and varsity. So therefore, since they cannot occur at the same time, yes. Because you can't be on JV, the probability of being on JV and varsity is equal to 0. Therefore, this is a mutually exclusive event. However, can you practice 44 times per week? Is that a mutually exclusive event to being on JV? No, because the probability of being on JV and practicing 4 times per week is not equal to 0. This actually can occur. So these two are not mutually exclusive events, whereas these two are mutually exclusive events. All right, let's discover independent events. Is being on JV and practicing 4 times per week an independent event? Well, to find this, you can say probability of them being on JV and practicing 4 times per week is this equal to the probability of them being on JV times the probability of them practicing 4 times per week. If these two are equal, then yes. So let's calculate this. The probability of them being on JV and practicing 4 times per week, well, we can go up to our sample space. The probability of them being on JV and practicing 4 times per week would be defined by our probability of them being on JV and practicing 4 times per week, which would be 40 out of 75. Is this equal to the probability of them being on JV times the probability of practicing 4 times per week? The probability of them being on JV, let's see, probability of them being on JV was 75 out of 150. And the probability of them practicing 4 times per week was 80 out of 150. Well, let's do the math. 75 times 80. 75 out of 150 times 80 out of 150 gives us the 4/15. And let's see if it's equal to our 40 out of 75. No, These numbers are not equal. 8 out of 15 is not equal to 4 out of 15, so therefore we can say these two events are not independent. All right, everyone, go ahead and pause your screens to complete this exit ticket. Let me know if you have any questions, and I look forward to seeing you all soon.